Hey, Mr. Herdum here. We're going to go over the nuclear reactions and we're going to go over some fission and fusion today here. So, what is a nuclear reaction and how is it different than a chemical reaction? Chemical reactions are atoms that are rearranged to form new substances. Okay? Only small energy changes take place. Okay? You don't produce enough energy to run a city from a chemical reaction. Okay? This only involves the valence electrons, which are the outermost electrons. Okay? So these points are very important here for chemical reactions. Okay? Nuclear reactions are atoms that have a change in number of the number of protons and or the number of neutrons. I always misspell neutrons. Okay? Remember that these involve the nucleus. That's why it's a nuclear reaction. Okay? It creates a different isotope or a different element. Okay? You're making new elements when you do nuclear reactions. You get large amounts of energy. Okay? Particles can be lost by fusion. No, I said fusion. I meant fission. Particles can be lost by fission, which I'll go over in a second here, or gained by fusion. Okay? So that's the difference between chemical reactions and nuclear reactions. Okay, fission versus fusion here. We are going to start off with fission. Okay? Fission is the splitting, or I should think this should say splits. Yeah, a heavy nucleus splits into two or smaller, more stable nuclei, produces a large amount of energy here. The classic reaction that we will ask you about is usually they take uranium 235 92 and they are going to split it apart into krypton 92. I think that's element 36. It is. And barium. Barium is 56. I'm getting old at my age. Okay. But notice that you're starting off with something that is huge. Uranium's huge because it has a lot of protons and neutrons. And you're splitting it into two smaller substances. Like that. Okay? Because this is the classic nuclear power plant reaction. That's where you do that reaction. You do it in a nuclear power plant. Okay? Now there's something called a chain reaction. First of all, you need something to initiate the reaction here. They have a neutron here. This is a neutron. To start the reaction. And if you notice here at the end of this reaction here, you have more neutrons. What these neutrons do is they find more uranium and break it apart, producing more neutrons. And then you produce more neutrons, and then you find more uranium and break it apart. That is why they call it a chain reaction here. Okay? That would be a controlled chain reaction. Uncontrolled chain reactions result in explosions and is what is used for the atomic bomb. Back in the 60s and 70s, you had to worry about this kind of sound. Yeah, that's an air raid sighting there. That's pretty much it. Back in the times there, they used to have to do drills and they used to hide under the desk, right? Or they would run into the basement and hide under the basements. in case of a atomic bomb or something like that. They used to practice that all the time in the States. Okay, controlled chain reactions for fusion are used in nuclear power plants. Okay, they can create energy through heating water and producing steam. The steam then turns the turbine here, connected to a generator, and produces electricity. Okay, there is lots of lead and concrete to prevent radiation from escaping. There are control rods that absorb the neutrons to avoid meltdowns, and liquid water is used to cool down the reactor and slows down the neutrons during fission. Okay, so here are the advantages of nuclear reactions that are fission done in a power plant. First of all, there is no air pollution. Second of all, lots of energy for little fuel. Okay? Disadvantages: risk of accident. Do you know who causes accidents at nuclear power plants? People that don't know what they're doing. You know. Okay? Or if you get hit by a hurricane or something like that. Okay? It is difficult, but not impossible, to dispose of nuclear waste. Okay, it's either usually stored on the nuclear power plant facility, or if they have a buildup of it, they actually send it to the Yucca Mountain in Nevada. They put it on a train and ship it out there. They send it out there because there's no people and there's no like water basin, and then they just bury it underground. Fun stuff there. Okay? So for our power plant here, so power plants, when they do their energy here, you start off with nuclear energy that is transformed into thermal energy, which is transformed into mechanical energy using the turbine, which is transformed into electrical energy that you can use. Okay? That is for power plants. Okay. Okay, fission can be also called radioactive decay. Okay. Besides the release of energy, these processes also tend to release gamma radiation. We'll go over that a little bit more later on. Gamma radiation is pretty much the most dangerous radiation you can have. It can cause cancer and lead to mutations. Okay. Oh my goodness, that's the next blank. Can cause cancer. And DNA mutations. I'll have to sing you the Mutant Birdie song sometime. Song I wrote about birdies being mutants. Okay. I was a kid though. I didn't like write it yesterday. Okay. Elements beyond bismuth. Bismuth is Bi on the periodic table, number 83. Are so large they have a hard time holding on to everything. That makes them very unstable, meaning they like to spontaneously decay and go back to elements that are smaller. Okay? Elements that have a great number of neutrons, greatly different than the number of protons are likely to decay. When these elements undergo an identity change, they have completed a transmutation. Okay, so again here, when you think of fission, you're starting off with one big product. Not one big product, one big reactant. Come on, Mr. Haradam. And you end up with two smaller products. Okay? That is what we are doing when we are doing fission. Okay? And that happens in nuclear power plants. Okay, time to go over the other type of reaction here, which is fusion. Let me find my notes here on fusion. Okay, here we go. Here's the notes on fusion here. Fusion is the opposite of fission. So when you're doing fusion here, you're taking two small reactants and you're forming something that is a one bigger product. Okay? The classic fusion reaction is when you take hydrogen and you add it to hydrogen and you make helium. Like that. That occurs on the sun. Notice I took two smaller elements and combined them to make one bigger element here. So in fusion, you take two or more lighter nucleates and you join them to form one large nucleus. Again, nuclear reactions produce a large amount of energy. Hey, the sun has a large amount of energy, just so you know. Hey, you also know what the sun has here? Okay, extremely high temperatures and pressures that allow for this reaction to cause fusion. The only place that fusion happens is the sun. They really can't do that on Earth yet because they don't have the containment to hold all that energy, and yeah, it's a mess. So fusion happens on the stars, including the sun. Okay. If you get an uncontrolled fusion reaction from hydrogen, this is how you make explosions. And eventually, you can have the hydrogen bomb. Okay. You guys are champions. The legend is